How does cleavage fracture look in fractography? Imagine breaking a glass and seeing a perfectly flat, shiny surface with smooth, mirror-like facets. That's a key sign of cleavage fracture in fractography. When materials fail in a brittle way, they often do so along specific crystallographic planes. These planes are like natural fault lines within the material's grains. The fracture surface appears flat and glossy, almost like a polished mirror, because there's little plastic deformation involved. You'll notice flat, smooth areas called cleavage facets. Each of these facets shows where the crack traveled through a single grain, splitting along a specific plane. These facets are usually uniform in appearance, giving the surface a consistent, shiny look. Sometimes you can see what are called river patterns or river lines. These are linear markings that radiate outward from where the crack started. They look like streams flowing across the surface and help trace the origin of the fracture. These lines are ridges, not steps, and they show the direction the crack moved within the grains. You might also see small step-like features on the surface. These are called cleavage steps and are formed by the crack moving sequentially along adjacent planes. They appear as tiny terraces or ledges on the fracture surface. Other markings such as feather markings, herringbone structures, tongues, microtwins, and Wallner lines can also be present. These features add more detail and help investigators understand how the crack propagated. The overall fracture surface in cleavage failure is flat and smooth, unlike ductile fractures that look rough and dimpled due to plastic deformation. Cleavage fractures happen suddenly and often cause catastrophic failure without warning. When analyzing a fractured component, spotting these flat, shiny facets with river lines and cleavage steps helps confirm a brittle failure mode. It indicates the material broke along specific crystallographic planes, often caused by low temperature, high strain rate, or material embrittlement. Using tools like scanning electron microscopes allows detailed observation of these features. Investigators look for the flat cleavage facets, river patterns, and associated markings to determine if the failure was caused by cleavage. Recognizing these signs helps in understanding why a component failed suddenly and what conditions led to the brittle fracture. So, in simple terms, cleavage fracture looks like a shiny, flat surface with smooth facets, river lines, and sometimes tiny steps, revealing a brittle failure along specific planes within the material's grains.